Welcome back to part B of example number 3, the pinball machine. In part A, we found that the energy lost was quite small, 0.0021 joules. In part B, we're going to look at how we can convert this to a force. We can say that essentially this energy that's being lost is exactly the work that was done by friction. 0.0021 joules, the non-rounded value, of course. This is the work done by friction, and we know that the force is the force times displacement times cosine theta. If we go back to the diagram, assume a ball is somewhere here or anywhere on this incline. The direction of the ball's motion is forward, up the incline. Okay, so that's my displacement. My force of friction is in the opposite direction. Okay, this is my force of friction. The angle between these two vectors is 180 degrees. So that might be something we're going to need in that previous equation. Another important thing we need to know is we actually need to know the displacement from the bottom to the very top of the incline. This 20 centimeters, unfortunately, is only the base of your field. It's not the actual hypotenuse. So I'm alluding to the fact that yes, we do need to use our Pythagoras to find our diagonal up my incline. So 5 centimeters and 20 centimeters is the two that I need. Okay, let's write this up here. So my displacement using Pythagoras is my square root of my one side, 5 centimeters, plus my 20 centimeters. Of course, my S is going to be in the centimeters, which we need to convert later on. Let's do that. So I have 5 squared plus 20 squared. I take the square root of this to get 20.615. 20.615, repeat, or whatever it is. This is in centimeters. Or 0.20615 meters. Okay, that's what I need. So we found a few things that are useful to us because we will need theta. Theta is 180 degrees. Now, you can also reason that since my force of friction is in the opposite direction of my displacement, my entire equation here, this should be negative. Oh, you could say that as well. Or you can say cosine is 180 degrees, and of course cosine 180 gives you -1. Our displacement was 0.20615 ... in meters. Work is given. We don't know the force. Solving for the force, I can move everything to the other side. S cos theta divided by S cos theta. Bam, bam. This gives me the force is equal to 0.0021 ... divided by my displacement 0.20615 ... and everything is a negative. And of course, you probably got a negative from your previous answer. Everything should cancel nicely. Anyhow, after taking the quotient, you will get something that looks like 1.0 times 10 to the power of -2 newtons. And there is your friction force up the incline for the ball. It actually should be rolling friction, if I didn't say that in the question, since the pinball supposedly rolls up the incline unless something funky happens. But anyhow, here is part B. Part C is a bonus question, kind of like a bonus. You can try that one on your own, and essentially is a review of your previous unit. I hope you got something out of these two videos to give you a sense of how everything can be integrated together, and also how understanding is more important than memorizing your equations. Before coming in for a test or a quiz, read your data booklet. See what is provided to you and what is not. With that, I leave you off. Good luck with your studying, with all your problems. Let me know if you want me to make another video, and may the force be always with you.